Pluto is a distant and mysterious dwarf planet that becomes as soon as a member of our solar device's planetary family. But latest startling announcements through main astrophysicists Neil deGrasse Tyson and Michio Kaku have delivered Pluto lower back into the highlight with a stunning revelation. They endorse that this icy globule is on an ability collision path with Neptune. However, how may want to this show up, and what would be the consequences of any such big event? Are we witnessing an extraordinary astronomical phenomenon, or is there something extra to this coming near cosmic collision? Be a part of us as we discover the possibilities of a Pluto-Neptune impact. Pluto, a former planet that became demoted to a dwarf planet in part because of its atypical orbit, stays a topic of fascination and look at in the astronomical network. In step with current predictions by means of main scientists, Pluto's trajectory is dangerously close to Neptune's. Main astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the red flag of a likely dangerous collision between these planets, which can pose a big threat to Earth. How is such an event even possible? Pluto's journey across the solar is unlike another planet in our solar system. It takes an incredible 248 years to complete a single orbit, which means in view that its discovery in 1930, it hasn't even finished one full revolution. However, the intrigue doesn't forestall there. Pluto's direction is marked by means of its distinctly elliptical shape, deviating significantly from the near-round orbits of the principal planets. What makes Pluto's orbit even extra peculiar is its inclination, angled at 17 degrees to the ecliptic aircraft. The path Pluto traces is an awful lot steeper in comparison to the opposite planets. This inclination and elliptical nature upload layers of complexity to its orbital pattern. One of the most exciting elements of Pluto's orbit is its intersection with Neptune's route. For about 20 years in each orbit, Pluto honestly comes towards the Sun than Neptune, defying what we would count on from their positions inside the Sun machine. This results in the herbal query: why hasn't Pluto collided with Neptune? The solution lies within the gravitational affects of other planets. The examine of Pluto's orbit started out quickly after its discovery. To start with, astronomers struggled to recognize its specific trajectory. Not like the alternative planets, whose orbits lie rather near the ecliptic plane, Pluto's route stood out with its steep inclination and elliptical shape. The mystery deepened with the realization that Pluto's orbit truly crosses Neptune's. The steadiness of Pluto's orbit amidst those complexities is proof of the intricacies of area mechanics. The three-body problem in area is set identifying how three things in space, like Pluto, Neptune, and the solar, move and have an effect on every other with their gravity. It's like trying to predict in which they may go primarily based on in which they begin and the way they pull on each other. In Pluto's case, this problem indicates how its path, Neptune's course, and the solar's gravity all work collectively in a complicated way. The phrases azimuthal libration and latitude libration, together with the VZK oscillation, are part of this puzzle. In step with astrophysicists, what is keeping all planets of their orbits is azimuthal libration. Inside the context of Pluto and Neptune, this time period way that every time Pluto crosses Neptune's orbit, it is placed as a minimum 90 degrees far away from Neptune. This spatial separation is essential in preventing their paths from colliding. Range libration, however, refers back to the vertical motion of a celestial frame in its orbit. For Pluto, this means that whilst it comes closest to Neptune or every other large planet, it's located notably above their orbital aircraft, providing an extra layer of protection from potential collisions. Any other essential factor on this equation is the VZK oscillation, named after scientists Bond, Zippel, and F, who studied how matters pass in area. It's about how three space gadgets, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pulling influences how they move. In Pluto's case, VZK allows us to understand why its path around the solar is so unusual. Despite the fact that Pluto's path seems all over the region, this oscillation allows maintain it shifting smoothly. For a long time, the VZK oscillation suggests that although matters in space appear wild and random, a few styles and regulations preserve the entirety so as. All of those additives assist keep Pluto's orbit solid, ensuring it would not crash into Neptune or get thrown off route. This three-body trouble facilitates in knowledge how these parts trade because of the way these area objects pull on every other. Studying this helps us find out about Pluto and our solar gadget, in addition to distant worlds and their stars. Numerical simulations inside the overdue 80s discovered that in spite of those stable homes, Pluto's orbit is technically chaotic, with minor deviations in initial situations leading to large differences over tens of millions of years. However, those particular houses of Pluto's orbit were determined to keep stability over noticeably long timescales, effectively preserving the chaos at bay. Latest PC checks have helped us recognize how the big planets like Neptune, Jupiter, and Saturn affect Pluto's path across the solar. Neptune has a special connection with Pluto, in which for each rounds Pluto makes across the solar, Neptune makes 3. This connection enables hold Pluto's path regular. However, Neptune is not the handiest one helping. Jupiter's gravity also performs a big element in preserving Pluto's orbit safe and stable, and Saturn helps a piece too. These checks show that Jupiter's gravity on my own is strong enough to make sure Pluto stays on a stable route for a surely long term, even billions of years. So it is like Neptune, Jupiter, and Saturn are all working together to ensure Pluto maintains shifting safely in space without strolling into hassle. Those phenomena are crucial in the context of the universe for retaining the order and predictability of space bodies' moves. Without those mechanisms, the solar gadget as we understand it might be a place of a great deal more chaos and unpredictability. Our bodies like Pluto should probably collide with others or be ejected from their strong paths, leading to a domino impact on other celestial bodies. For Pluto, specifically with talks about it probably crashing into Neptune in the future, understanding its orbit is honestly critical. This gives us a clearer photo of the Sun system's dynamic nature. The case of Pluto demonstrates how even the most seemingly risky orbits can obtain a nation of equilibrium through the complex interaction of gravitational forces and orbital mechanics. It also suggests the importance of continuous remark and examine of these phenomena to comprehend our area in the universe higher. Exploring the depths of area regularly leads us to confront the unpredictable nature of celestial bodies, and Pluto's orbit is a high example of this unpredictability. The idea of orbital chaos, which refers back to the sensitive dependence of a celestial frame's direction on its preliminary situations, is vividly illustrated within the case of Pluto. This means that even moderate versions within the dwarf planet's function or velocity can considerably change its lengthy-term orbit. Using PC simulations has been extremely good beneficial for scientists to determine out how Pluto moves in area. These simulations use complex math to imitate how Pluto and other area gadgets like Neptune pull on every other. By converting little details within the simulations, astronomers can see how even small tweaks can make a large distinction in which Pluto goes. Returned in the overdue 1980s, these simulations confirmed something truly exciting approximately Pluto's route. Even though it has such things as azimuthal and range libration to maintain it constant, its orbit can still be quite wild and unpredictable. If you start off with only a tiny distinction in where Pluto is or how speedy it's transferring, over a few years its route can end up searching honestly one of a kind. But regardless of all this chaos, Pluto's orbit remains strong for a great long time, like billions of years. This means Pluto's adventure across the Sun has a form of order to it, although it appears all over the region before everything. Predicting cosmic events, especially whilst it includes chaotic orbits like Pluto's, poses extensive demanding situations. The inherent unpredictability of those systems means that long-term forecasts are frequently fraught with uncertainties. Whilst numerical simulations provide an effective way to apprehend and count on the future paths of celestial bodies, additionally they highlight the restrictions in our predictive competencies. Those fashions depend closely on the accuracy of initial conditions and the complexity of the interactions they simulate. Any mild errors or oversimplification can result in vastly extraordinary results, making specific predictions a daunting undertaking. Furthermore, the chaotic nature of celestial orbits like Pluto's reminds us of the ever-evolving and dynamic nature of the universe. Whilst we've made giant strides in knowledge area, the case of Pluto reminds us that our know-how about the universe nonetheless stays restricted. Know-how the gravitational influences of the massive planets on Pluto's orbit affords valuable insights into the wider dynamics of the Sun gadget. It indicates how the presence and function of each planet may have a long way achieving results, influencing the steadiness and trajectory of different bodies in the gadget. So why are foremost astrophysicists best now raising issues approximately a likely collision between Pluto and Neptune no matter these types of complex forces seeking to keep such an event from happening? Neil deGrasse Tyson, a prominent astrophysicist and a pivotal parent in popularizing astronomy, affords a completely unique angle on the mysteries of our solar machine, in particular the fascinating case of Pluto. Tyson, recognized for his function in the reclassification of Pluto from a planet to a dwarf planet, gives insightful remark at the evolving nature of celestial mechanics and the general public's fascination with the unknown realms of area. Tyson's stance on Pluto's reclassification is rooted in the ever-increasing understanding of our solar device. He perspectives the reclassification as not a demotion, however, a necessary model to our developing know-how of the many our bodies orbiting our sun. Tyson's approach to celestial mechanics is one in every of continuous getting to know and addition. He sees the complexities of orbits consisting of Pluto's as a reminder of ways a good deal there may be nonetheless to find out in area. The intrigue of these unknowns, particularly the potential interactions among Pluto and Neptune, highlights the dynamic and unpredictable nature of our solar machine. His paintings emphasizes that the extra we find about space, the greater questions rise up, pushing us to explore in addition and refine our knowledge of the cosmos. Michio Kaku, another renowned physicist and futurist, offers a unique yet complementary perspective on the mysteries of space, focusing at the regularly unpredictable forces that form our universe. Kaku is understood for his capacity to bridge complicated scientific principles with futuristic visions, making him a full-size voice in discussions about celestial mechanics and the wider implications for humanity. Kaku's perspectives on Pluto and its orbit emphasize the need for non-stop commentary and superior modeling to anticipate and apprehend capacity cosmic occasions. He sees the interactions among celestial bodies as an important region of take a look at, no longer only for instructional curiosity but for sensible implications. The capability collision among Pluto and Neptune, as an example, is not just a theoretical situation but a reminder of the dynamic and frequently chaotic nature of space. Kaku's futurist outlook pushes us to do not forget the wider implications of such occasions, from the impact on our knowledge of the solar gadget to the potential need for future space interventions. Kaku's attitude underscores the importance of being prepared for the unexpected in space. His paintings suggest that the more we apprehend the forces at play, the higher equipped we can be to navigate and doubtlessly mitigate the outcomes of cosmic events. Each Tyson and Kaku's views converge on the concept that space is a realm of countless discovery and that our contemporary knowledge, whilst considerable, continues to be limited. Their emphasis on the want for continuous exploration and advanced modeling reflects the evolving nature of area technology. They highlight the importance of now not simply information celestial mechanics as they may be now but expecting how they might trade inside the future. The ability collision among Pluto and Neptune serves as a case look at for the wider demanding situations and opportunities in area exploration. It underscores the need for robust scientific inquiry, advanced era, and a willingness to adapt our information as new records emerges. For Tyson and Kaku, the mysteries of space exemplified by way of Pluto's orbit are a name to motion for the clinical network and humanity at massive to maintain pushing the bounds of our knowledge. There is a popular scientific consensus that for the foreseeable future, the orbits of Pluto and Neptune remain stable because of their mean movement resonance and the diverse gravitational influences acting on them. Therefore, a right-away collision among Pluto and Neptune is distinctly unlikely. But the complexities and ability perturbations in orbital dynamics suggest that astronomers must hold to display and study these celestial bodies to better apprehend their lengthy time period behaviors and any capability risks they may pose. While the situation of a Pluto-Neptune collision is basically speculative and considered unbelievable with our current knowledge, it underscores the significance of continuous research and statement in astronomy. Advances in technology, including stepped-forward telescopes and PC simulations, will assist astronomers refine their fashions and predictions, ensuring that we live knowledgeable about the dynamic and ever-converting nature of our sun gadget. Tyson's perspective on Pluto's reclassification and Kaku's emphasis on the unpredictable nature of celestial mechanics each underscore the need for non-stop exploration and a bendy expertise of our universe. The capability collision state of affairs, at the same time as highlighting the dynamic and complex interactions inside our sun machine,